down at the ring on your finger, or at the thin trace of metal soldered inside the phone in your hand. That gold is older than this room, older than every continent, every ocean, every species, older than the planet itself. Each atom was forged in a cataclysm so violent it would sterilize any living world inside a 36 light-year radius. The iron crusts of two dead stars collided in a single millisecond, and the resulting fireball flung 150 Earth masses of fresh gold into the dark. The piece you are wearing began its life there. This is the story your jewelry has never told you. Because nearly everything we believe about where gold comes from turns out to be wrong. Ask anyone where gold comes from, and the answer comes back instantly. The ground, a mine, a riverbed, maybe South Africa, maybe California in 1849. The image is always the same. A man with a pan, watching for that yellow gleam in the silt. It is a perfectly reasonable answer. Every flake we have ever held was chipped out of rock. But Earth is not the source. Earth is the storage locker. Pull back from the pan. Pull back from the rock face. Most science-curious people know the next layer of the answer. Heavy elements are not native to Earth. They were cooked inside stars. A star spends its life smashing light atoms together. Hydrogen into helium, helium into carbon, carbon into oxygen. Up the table. Gold is element 79. Somewhere the logic goes, a star must have done the cooking. Every wedding band, stellar leftovers. That answer is closer, but still wrong. The standard upgrade is the supernova. When a giant star runs out of fuel and dies, it does not go quietly. It detonates with the brightness of an entire galaxy, scattering its ashes across light years. For decades, every astronomy textbook ended right there. Supernovae explode. Heavy elements ride the shock wave outward. Planets coalesce. Done. But the math never quite added up. Start with the simplest test. Could the Earth itself just bake more gold under our feet? The core is a sphere of liquid metal at 5,400 degrees Celsius, hotter than the surface of the sun. And it is not even close. To forge anything heavier than iron takes temperatures and pressures the Earth's interior misses by a factor of millions. By stellar standards, the core of our planet is a refrigerator. Whatever gold ended up here was already gold when it arrived. Move up to the star. A normal star is a furnace where lighter atoms fuse into heavier ones, and every fusion releases a sliver of energy. That energy holds the star up against its own gravity. But the process has a hard limit. The atom of iron, element 26, sits at the most stable point on the periodic table. Fuse anything past iron, and the reaction no longer releases energy, it consumes it. For the star, that is a death sentence. Iron is the wall. So what about supernovae? A supernova brute forces past the iron wall by detonating the entire star at once. In that flash, a soup of neutrons and protons does forge a modest zoo of heavy elements. The story used to end here. Then in 2017, instruments on 3 continents picked up a signal that did not match any supernova ever measured. The element factory we had been crediting was not the main factory at all. Something rarer was doing most of the work. Every civilization that ever existed valued gold. The Egyptians, the Romans, the Aztecs, every empire, every religion, every currency, and not one of them, in all of recorded history, had any idea where it actually came from. Until 2017. Picture compressing the entire mass of our sun into a ball you could drive across in 20 minutes. Picture squeezing it tighter, until the atoms themselves crack open. until electrons are crushed into protons. What remains is a sea of neutrons, packed shoulder to shoulder. That object is a neutron star. The numbers stop sounding like physics and start sounding like a misprint. 1 teaspoon of this material weighs 1 billion metric tons. It is the densest object the universe builds that is not a black hole. Now picture two of them, locked in a death spiral, orbiting each other thousands of times a second, falling inward, faster and faster, until they meet. The collision is called a kilonova. For a heartbeat, that fireball is hotter than the interior of any supernova. The iron crust of both stars is ripped apart and rammed by a tidal wave of free neutrons. In that millisecond, the rules that constrain ordinary stars no longer apply. The element factory is open. What comes out of it should be impossible. From a single collision, roughly 150 Earth masses of gold. In seconds, one event, one moment. This is the real reason gold is rare. Not because the universe is stingy, because the only forge that makes it almost never runs. In our galaxy, it happens perhaps once every 100,000 years. You are wearing the output of an event that your entire civilization will never witness. The mechanism has a name: the rapid neutron capture process. Iron goes in, neutrons flood it. The nucleus swells, cracks, climbs, one rung at a time up the periodic table, from iron to gold, in less time than it takes to blink. But that explains the gold in the galaxy, not the gold in your ring. The Earth formed 4.6 billion years ago from a settling disk of dust. And almost every gold atom in that disk had a problem. Gold is heavy. Gold bonds with iron. As the young planet melted into layers, nearly all of its primordial gold sank straight through the mantle and disappeared into the core. The crust was left empty. Then came a second act. Roughly 4 billion years ago, the inner solar system was raked by a storm of asteroids. Many carried trace gold of their own, frozen into rock since the disk first cooled. They hammered the young Earth. Thin veins of yellow metal threaded the stone. Every coin in every vault is airmail. And here's the part nobody mentions at the jewelry counter. The gold in the Earth's core, the gold that fell in during planet formation, is still down there. It has never moved. Enough of it to coat the entire surface of our planet in a layer of pure 24-karat gold, knee-deep. We will never reach it. Every ring, every bar in every vault, every microscopic trace on a circuit board, all of it is the scratched leftover, the crumbs from an asteroid storm. Look at your wedding band one more time. Older than the chair beneath you, older than the dinosaurs, older than the planet itself. Forged when two impossible objects shattered each other across 140 million light-years of dark. Carried here on the asteroid storm. We value gold because it shines. The universe values it because it is almost impossible to make.